Suppose that we have two series s of n, b of n, with s of n and b of n more than or equal 0 for all n, and s of n is less than or equal b of n for all n. Then if b of n is convergent, so is s of n, and if s of n is divergent, so is b of n. Limit comparison test states that suppose that we have the two series s of n, b of n, with s of n and b of n more than or equal 0. Define C, which equals the limit of s of n over b of n as n approach infinity. Or the limit of b of n over s of n. If C is positive and is finite, then either both series converge or both series diverge. Example 1. Use the comparison test to determine whether the following series converge or diverge. The infinite series of 1 over 3 to the power of n plus n. Solution: s of n equal 1 over 3 to the power of n plus n. And we need to find a second series so that b of n is more than or equal s of n. And that series is 1 over 3 to the power of n. Since the absolute value of r is less than 1, b of n converge, and so an is. Example 2. Determine whether the following series converge or diverge. The infinite series of 1 over 3 to the power of n minus n. In solution, we need to find a second series that we can determine the convergence of easily. And the series is also 1 over 3 to the power of n. And we cannot use comparison test since b of n is less than or equal s of n. So instead of that, we will use the limit comparison test. C equals the limit of b of n over s of n as n approach infinity. And that equal 1 over 3 to the power of n times 3 to the power of n minus n over 1. And the answer is 1. So C is positive and finite, so by the limit comparison test, s of n must converge since b of n converge.